functions multiplying each other. So the formula of part by part, if we have integral of f of x times what? G of x dx. It's equivalent to what? Formula sheet?
Times G
F of x times G of x minus what? Integral of f prime times what? G of x. So we can use this integration if we have two functions multiplying each other. If we have our f of x times what? G of x. And we said in order for us to identify f of x and g of x, we need to identify any Lear tag. So we said now we'll be using the arrangement called Lear tag. We said there are many arrangements that you can use. So in Lear tag, we said L stands for logarithmic function, I stands for the inverse. A stands for what? Algebra, right? T stands for in trigonometry. E stands for exponential. C stands for a constant. C sharp, So now we're given a question there whereby we're given what? 1 over A, B multiplied by the arc what? Arc inverse of BX over what? A. So we want to integrate. So what we are seeing two functions multiplying each other. Why we say two functions? Because we have our constant. 1 over AB is a constant. So simply means if we're supposed to use our arrangement, the Lear tag, we can say we have this function, the constant. And we also have what? This is called what? Inverse of trigonometry. So we have what? So we can say which one is first between the two according to the arrangement. Inverse. So we name inverse as 1 and then C as what? 2. C sharp. So the first function that we have identified there, it tells us what function do we have first. The first function is f of x according to formula. So because we have identified 1 here, it means our f of x is what? It's inverse of trigonometry. So you're going to say arc what? Arc tan of what? Bx over a. So the second function will become in 1 over what? AB. C sharp. So therefore, we find a derivative of this function. What is the derivative of this? We use the formula sheet. The formula sheet will tell us how do we differentiate this. The formula sheet here we must put the derivative of f of x. Right? So what is the derivative of f of x? Of course, it will be what? B over A. And when you derive 3x, what's the derivative of 3x? You said it's the constant. So what is the derivative? Our constant is B over A. So it means our it will be B over A. You put the derivative on the numerator, and then here formula sheet is to tell us which is 1 plus f of x squared. And then our f of x is the whole function that we have. Bx over what? A all raised to power 2. So if you want, you can apply the laws of exponent that these can be squared to b and squared to the what? X squared, and also squared to what? To a. So this, when we write it in a simplest form, we can say basically the derivative of that is 1 plus in b what? B squared x what? X squared over what? A squared. C sharp. Yeah. So here this side we integrate. When you integrate a constant, you know to this it will be 1 over what? AB x. Because we are looking for the integration this side. So we are integrating this side and then we do what? Integration. C sharp. So our job or our first step is to substitute it to the formula of part by part. Is that right? Yeah. So therefore, simply means since we know the formula of part by part, therefore we'll arrive and say we have our f of x. What's our f of x? We have already identified. So it means arc tan of what? Bx over a multiplied by your g. You also have your g, which is 1 over what? Abx. Minus. Remember, minus is part of the formula of part by part. Minus. Yeah, minus integral. What is derivative of f of x is this one, so we're going to say a over b over 1 plus b squared x squared a squared over a squared, multiply by what? G of x. What is our g of x? You said it's 1 over a b x. Don't forget also to put the x because it's also there on our formula. So therefore we have used our formula of part and part. So when we check the first two terms, already does not have the integration sign. So this tells us this is already part of the solution, or it's already our solution. So simply means we can leave it the way it is. Some they will prefer to start with this, the order does not matter because it's multiplication. So already it's part of our solution, but because here we have the integral sign, tell us that we must integrate. So number one, we can start by simplifying this. So how can we simplify this? Is to identify the constant outside the integral. So what's our constant?
A over b.
Remember there on the numerator you have this, A. And then on the other side we have what? 1 over AB. Right, Mr. So what will happen now? B and B cancel, or if you want to write this, it's like that. This and this cancel. So right, Mr. So who's over Salaman constant 1 over A. We agree, Mr. So we take 1 over A as our what? Constant.
1 over a squared.
1 over a squared, because a times a, Okay. Therefore, we are left with what inside? We'll be left with, remember, x in our power. Numerator also x, and then with denominator, you have that, the way it is. So from here, it simply means we will have to integrate this. So whereby you are using your U method or you use what? Your inspection. Yeah, but let's use EU method. So if I let this to be my U, so what is it? You know, this will be what? 0 for 1. You drive here, meaning we're gonna invert 2. So when you invert 2, it will be 2b squared over what? A squared x. So it will be able to cancel with x. So we'll make what? The x will be the subject of the formula. Simply means it will be the u divided by the derivative. Any u method, when we use it, it must be able to cancel the x term. So now when we substitute this in terms of, don't forget, we already have part of the solution. Minus 1 over a squared. So when you come to this part, we want to replace everything in terms of what? In terms of EU. So you have x, so ax will remain like that. Let me write it down so that it does not touch each other. So remember, we already have part of the solution turn to this. It was already part of the solution. We focus on the integral part. So on the integral part, remember now we want to replace in terms of EU. So x, it's like that. We say this is already our what? Our u. And the dx, we already know what is the x. We replace also that to b squared over what? A squared x. So what will happen? You see x and x will do what? Will cancel. So it simply means we can integrate that. When x cancel, what are we left with there? Remember, this is part of the solution. We'll be left with a constant. So what we must do, we can identify the constant outside. So this is 1 over 2b squared over a squared. Simply means use of a squared over what? 2b squared. We agree, because you have 1 over 2 b squared over a squared. So mathematically, this will be what? A squared over what? 2b squared. So we take out the constant. So we're going to take this. Use a multiply 1 over a squared. So we can simplify it. And already outside we have 1 over a squared. We are taking out the constant of what? A squared over what? 2b. So what will happen? A squared will cancel. So it means we'll be left with a constant of 1 over 2b squared. We agree with that? Then last, suddenly 1 over u. What is 1 over u? This is a constant, it remains the same, then we open up brackets. Once then you say this is in u plus c. So at the end of the day, we're going to replace the value of u because we know what is the value of u. Yeah. Any question? C sharp. Yeah, one cut.